So in these problems, we want to be able to solve for a different variable than the one that is currently solved for, and that is complicated by the fact that there's nothing but letters in here. There's no numbers, so that makes it a little tricky to think about. So this particular one up here on the top left is currently solved for p because it's p equals a bunch of stuff. And what we want is we want to solve it for t. We want to get it so that it's t equals everything else. Okay, now how are we going to manage that? Well, very carefully. So you want to look at it. I'm going to make this a little bigger so you can see. You say, okay, I don't want this denominator. This denominator part just is terrible. So what I'm going to do is I'm going to multiply by v. But if you do it to the left, or excuse me, to the right, you have to do it to the left as well to keep everything fair and balanced and all that good stuff. Okay. Now what happens over here? If you multiply by v, then the v in the numerator up here and the v in the denominator down here, when you divide v over v like that, what happens? It cancels, right? It divides, right? V over v divides to 1. So that part's gone. So now over on the left you have Vp equals nRt. Now you want to get the t part by itself. So you want to get rid of this n and this r. Now they are currently multiplied by t. So what you're going to do is you're going to divide by n and r. That way you can take n and r, divide it by n and r. It's going to go away. But you can't do it to the left without doing it to the right as well. So n and r over here. So you get t is equal to Vp over nr. All right, there's your final result right there. Now notice I flipped sides, right, because t was on the right and Vp over nr was on the left, but with equations it doesn't matter which one's on the left and which one's on the right. So there you go, that's the work for that one. All right, now let's do it again for this one. By the way, these are real formulas. I didn't get these out of the sky. They're real formulas for real problems. Just, you don't necessarily know what they are, right? Okay, so let's see here. So I have I equals capital E, or that's really an epsilon, actually. It's a Greek letter, over r plus little r. Now our goal is to get little r by itself. That's what we want. We want to solve this for little r down here. Okay. Well, the first thing you should notice is you don't want it in the denominator like this. This is terrible. Actually, the other first thing you should notice is that this is grouped together. Remember, the order of operations groups together those numerators and denominators for you. So since it's grouped together, what I'm going to do is I'm going to multiply by it because I want to get it out of there. Oops, if I could highlight that. Okay, so I'm going to multiply by r plus r. The reason I'm doing that is that I'll be able to cancel, right? Divide. R plus r over r plus r. I mean, if you really like what you're doing is r plus r over 1, if you want to think of it that way. And when you do that, it divides away, right? Oops. R plus r over r plus r is gone. Now the trick is that you can't do it to just one side without doing it to the other. So I'm also going to multiply by r plus r over here, over 1, if you want to think of it that way. Okay, so now what does that mean that you've got, right? So you've got r plus r times I, and then here it's gone. So all you have left over here is this little epsilon guy. Okay, looks like an E, I know. And then over on this side you have r plus r, capital R plus little r times I. Okay, now you're trying to get the little r by itself, so you don't really like the fact that it's in this parentheses thing. So your next mission is to go capital Ri plus little ri, right? You're distributing. Okay, so I took I and sent it to the capital R, took I and multiplied it by the little r you distributed. You're still trying to get this little guy by himself, so you need to get this capital Ri the heck out of there. It's not good for anybody to be in there. So you minus Ri from both sides. Oops. There we go. Now what's going to happen? If you have Ri and you subtract away Ri, that's going to turn into 0, right? And then over on the right hand side, those aren't like terms. So you get this little epsilon thing minus Ri. All right, now you're still trying to get this little r guy by himself. You want him on his own, right? That's why we subtracted away the capital Ri. So you multiplied by the I to get this distributed because you wanted that little r out of those parentheses. So you multiplied to get it out of the parentheses. Now you subtracted to get rid of that capital R thing. You didn't want that. And now you don't want this I part either. And that operation there is multiplication. So to get rid of multiplying, you divide. So you're going to divide by capital I. And of course, if you do it to the left, you got to do it to the right to keep it fair and balanced. Now what happens when you take Ri over over I? Sorry, I had to align this a little bit better. It was driving me nuts. Okay, so when you take Ri over little ri, the little i's are going to cancel, right? The capital I's are going to cancel. They're going to divide away because I over I makes 1, right? So what happens when you have r times 1? You just get r equals, and then over here you have this. That's your final result. I know it's not pretty, but you know, that's what it is. Now if you wanted to, you could also write it, let's see, epsilon over I minus capital R, right? Because in this back term, the i's would cancel, but of course they wouldn't divide away in that front term, right? So that's another way you can write it. So either way is completely fine. But those are your two results. Just don't forget, you can't divide I over I in the back term without doing it in the front term as well. This is division in the middle. Division means you have to do it to both of those things in the numerator, not just the second one because there's an I there, but the first one as well. And the first one has an E over I, or epsilon over I, minus, and then R over, excuse me, Ri over I, the i's would cancel in that back term, or divide away. All right, now what about C? We want to solve this for T1. Well, this one's actually a little bit easier than the last one we did, believe it or not. I know it doesn't look like it because it has so many fractions. But remember, if you want to solve it for T1, what you can do, because this is a proportion, so P1 V1 over T1 equals P2 V2 over T2, what you can do is cross multiply, right? Remember cross multiplication? Yep, you can use it here. This is one of the few cases where you can. So how's that going to look? It's going to say T2 times P, crap, there it is, P1 V1 is equal to T1 times P2 V2. Okay? Now you're trying to get T1 by itself. So T1 is currently multiplied by all this stuff. So to undo multiplication, we divide, right? As we're going to in a second. So you divide both sides, right, by P2 V2. You got to do it on the left to keep it fair and balanced. There we go. So over here, when you have P2 V2 over itself, it divides away to 1. And 1 times T1 is T1. So that's gone. So you have T1 equals this big thing. Nothing divides away, nothing is gotten rid of, nothing cancels. You're all set. So I told you that one would be easier. Cross multiplication is a wonderful thing. All right, last one, D, which is another hard one again. D is a lot like B, the one we did above. That was more complicated because it's got that addition part in that denominator. Okay, so let's see here. We want to solve this for x. Of course we do, because it would be too easy to solve it for a. All right, so the first thing I'm going to do is we're going to multiply by that denominator. We want this denominator to go away. But if you do it over here to the right, you have to do it over here to the left as well. Keep things fair and balanced. Okay. Now, why in the world did I multiply by that? It looks so hard and difficult. Well, I did it because if I have something like 1 plus bx and I divide it by the same thing, 1 plus bx, I get 1. And 1 times a is a. So the right-hand side of this equation is now a. Now the left-hand side, remember what you're trying to do. You're trying to get the x by itself. So you needed to get the heck out of these parentheses. So your first mission is to distribute. So you multiply. C times 1 makes C. C times B times x makes BCX, or CBX if you want, whatever. You're trying to get x on is a little lonesome, so you need to get rid of this adding of c business. So what you do is you subtract c from both sides. So you subtract c over here, hold on, and subtract c over here. Now, on the left, when you take c and you subtract c, it goes away, right? So this part makes 0. C take away c is 0, so all you're left with is bcx equals, on the right, you have an a take away a c. Well, those aren't like terms, so you just write a minus c. You can't combine them or anything. Now, you have b times c times x. You want to get x on his own. So you're going to divide both sides by bc. That'll make the bc part go away. But again, to be fair, you've got to do it over here on the right as well. Right? So that's going to leave you, let's see, bc divides away, right? bc divided by bc makes 1. 1 times x is just x. So all you're left with over there is x equals a minus c over bc. And there's no point in even trying to simplify that because it's not going to be pretty, because b is not in either one of these terms in the numerator. So we're actually done right there. So the hardest one on this whole page was actually letter B, believe it or not. I know letter B doesn't look like it would be harder, but it was. Letter B was the hardest one. A was the easiest. Okay, we're done with that page. I'll meet you back here for more talks on the next problem. See you then.